Hello, listeners. This is Mike, your host. If you are enjoying these archive episodes, please consider supporting the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. Hopefully, with your support, I can continue to release these archive episodes. Thanks. Hello and welcome. This is Michael Annis, and you're listening to episode 151 of the Space Rocket History Podcast. The march to 200 begins. And now, Zond 4. When we last left the Soviet Union, they had somewhat successfully landed a probe on Venus, and they had completed the automatic docking of two Soyuz 7K OK spacecrafts. However, they did not reach their goal of a circumlunar flight in time for the 50th anniversary of the glorious revolution. As I am sure you recall, in November of 1967, the United States launched a Saturn V carrying a mock-up of the lunar module. The mission was called Apollo 4. It lifted nearly 140 metric tons into near-Earth orbit. After news of the American success reached the Kremlin, the Central Committee Secretary, Ustinov, immediately asked the Minister of Machine Building, Afanasyev, for an update on the N1 L3 project and how the Soviets should respond to the U.S. successes. The N1 had several failures during testing, and the L3 was at least 6 months from being ready to go. Then, on November 22, 1967, a Proton rocket carrying a 7K L1 spacecraft fell back to Earth shortly after its launch due to a second-stage failure. The numerous problems and failures finally prompted the Politburo to lose faith in OKB-1's chief designer, Vasily Mishin, and they decided to step in to help solve the problems at OKB-1. On January 23, 1968, the Minister of Machine Building, Sergei Afanasyev, was dispatched to OKB-1 to straighten things out. He was accompanied by Tyulin, his deputy, and Kirimov, the head of the Central Directorate of Space Forces. A meeting was held with senior staff of OKB-1, including Chief Designer Vasily Mishin. At the meeting, Afanasyev addressed the group first. This is what he said, quote, "After our rise in space, we have been experiencing a continuous fall. We are in a very serious situation. The Politburo no longer believes in our promises. Very many organizations are just spinning their wheels. Your factory, number 88, isn't busy. Everyone is trying to invent and remake his systems without factoring in production stock and outside experience. Nobody has any respect for his or her own words or promises. There isn't a single decree that hasn't missed its deadline by a year, 2 years, or even more. Things are going very badly in the space field, and especially where Comrade Mission is concerned. We are like a rabbit facing a boa constrictor. It is the duty of all of us to correct Chief Designer Comrade Mission. We respect him as a scientist, but he must also consider other people. Many of them understand as well as he does, but he doesn't want to listen to them. Now I'm going to pause here. Keep in mind, Mission is in the room hearing this, while Havanashev is addressing him in the third person as though he was not present. Afanasyev continued, quote, "In the U.S., they are working day and night on the Apollo program. They complain that the lunar module schedule has been disrupted by 80 hours. We find that amusing. Our schedules are disrupted not by hours, but by hundreds of days. You, at OKB-1, the head organization, need to make a turnaround and right away. The Ministry of Machine Building views you as an organization that is operating very poorly. As of now, there is no serious analysis of the prospects for the UR500K complex and the 7KL1. And we have no confidence in the circumlunar flight. We don't even know why it is necessary. Comrade Mission doesn't take into account the experience of others. Out of the 24 spacecraft you've planned, only 16 have been launched. Nuclear submarines are more complex, but Mikheyev doesn't fail to meet deadlines like OKB-1 does. Mission is bad when it comes to reliability processes. We need to change the work method. We need to review the managerial structure both at the ministry and at OKB-1. Your people need to develop a special solid propellant rocket complex. We can't continue to behave like amateurs. The 7K01, L1, and L3 programs are constantly changing. You've been given tremendous resources and you're driving the entire country into a dead end. The Politburo has instructed me to review the space program yet again and make things happen faster. In the U.S., Saturn V is moving along without a hitch. Over there, company directors are meeting every month. The capitalists have managed to dovetail their interest very well, and we can't make our chief designers, communists, even work together in harmony. Mission's cockiness will lead us to no good. We must correct the structure. We need a system that has 1. An OKB chief or director, 2. A chief designer, and 3. A chief leader and chief designers for each of the programs, 7K, L1, N1, L3, and RT2. It's been pointed out to me that Comrade Mission has many personal shortcomings, and this is hurting our business. Everyone still remembers Korolov's style of operating. You need to urgently review the entire N1 program and finally tell the truth. You have committed design errors, and now you're afraid to admit it. The N1 was built for a 75 metric ton payload, and then it was adapted for 95 metric tons. The Saturn V gives 120 and promises 140 metric tons. Who among you is responsible for such blunders? And the Saturn V launch weight is less than that of the N1. I'm not going to abdicate responsibility. These are the ministry's blunders. Where were the expert commissions and our scientists at the head institute looking? Glushko requested that he be assigned the hydrogen-oxygen engine, but Comrade Mission is being capricious. He doesn't try to compromise with Glushko. On the contrary, he exacerbates relations with him. I was told that Mission was the one who started the rift between Korolev and Glushko over the N1. We have a terrible fear of good cooperation between the chief designers. The N1 is way behind schedule, and they're asking me in the Communist Central Committee why I'm not punishing anyone. I could hand out reprimands. My colleagues would support me, but this will hardly help. How can Mission and his deputies be made to answer for everything they do? Projects need to be strictly distributed among Mission's deputies. For example, Okapkin, N1, Shabarov, L1, Sadovsky, solid propellant engines, Bushayev, spacecraft, Chertok, all control systems, and so on. In the collegium of the ministry, we will now regularly do a thorough examination project by project. I will demand that all matters be brought to a head. No more studying schedules that we don't stick to. State discipline has fallen. All of you, and I along with you, are soon going to be called to account by the party for idle chatter. At the lowest levels among your rank-and-file co-workers, life goes on quietly and smoothly. There is no emotion, no stress. An intense tongue-lashing is needed. You need to rally your people up the way you knew how to do under Korolev. After all, Korolev didn't achieve brilliant success all by himself. He did it with your help. We're going to develop a new complex for the RT-2. I'm issuing the order myself. Don't hold your breath waiting for Comrade Mission's proposals. We know that even when Korolev was alive, Mission was against solid propellant rockets. Korolev began this work, and we won't allow Mission to lay this combat missile to rest. Space is a political issue and not just nuts and bolts. This is the nation's prestige. I am attaching a great deal of significance to today's meeting. We will need to turn things around. Why is there no standardization of design, equipment, and developmental testing for the 7K, OK, L1, and L3? You promised that everything would be identical and standardized. Does this mean that it's all a sham? You proposed the 7K for the moon, and virtually nothing remained of the 7K in the lunar designs. You promised to take the main system of all three vehicles for developmental testing. You yourself assumed a sensible engineering policy, and then you abandon it. You're pulling the entire ministry into a whirlpool. End quote. Needless to say, after a speech like that, organizational changes would be made. Mission remained at the top of OKB-1, functioning as a director. The various projects were assigned to new chief designers reporting to Mission. Mission was actually pleased with the selection of Yuri Pavlovich Semyonov for the lead designer for the 7K L1 circumlunar flight. The reorganization also helped separate Semyonov and Topol, who was the lead of the 7K OK project, because they were not working well together. The work atmosphere became much more pleasant, but there were still more than enough technical problems, especially related to the control and navigation, which had to be worked out to achieve a circumlunar flight. And the question still remained: when will a human being fly around the moon? With the organizational changes made to suit Afanasyev, we could now move on to the 7KL1 Zond 4. The 7KL1 was based on the Soyuz 7K OK, with several components taken out to reduce the vehicle weight. The most notable modification was the removal of the entire orbital module and the docking hardware, since no rendezvous would be needed. It was replaced with a support cone and a high-gain parabolic antenna. Also, the reserve parachute was removed. The additions made were the gyro platform, star navigation sensors for the far space navigation, and a primitive computer. The Soviets did not have the capability to build fuel cells like those used in Gemini, but with the mission being so short, the L1 might possibly could make it with just batteries, but it was decided not to take the risk and solar panels were installed. The spacecraft was capable of carrying 2 cosmonauts. Now, a word about the launch vehicle for the 7K L1. It was called the Proton. The Proton began its life as a super heavy ICBM. It was designed to launch 100 megaton thermonuclear weapons over a distance of 13,000 kilometers. It was hugely oversized for an ICBM and was never deployed in that capacity. It was the brainchild of Vladimir Chelomy's design bureau as a foil to Sergei Korolov's N-1 rocket. Korolev openly opposed Proton and Chelomy's other designs for their use of toxic propellants. The Proton was 53 meters high with a diameter of 24 feet. It could be configured with 3 or 4 stages. The 3-stage version weighed 694 metric tons. It was capable of putting 22.8 metric tons into low Earth orbit. It was just powerful enough to send a 7K L1 on a free return trajectory around the moon without going into lunar orbit. A rushed development program led to dozens of failures between 1965 and 72. Proton did not complete its state trials until 1977, at which point it was judged to be about 90% reliable. Now a word about Zond. Zond is the Russian word for probe. Zond was the name given to 2 distinct series of Soviet unmanned space vehicles undertaken from 1964 to 1970. The first series, based on the 3MV planetary probe, was intended to gather information about nearby planets. The second series of test spacecraft being a precursor to manned circumlunar flights. Zond 4 would use the 7K L1 spacecraft and the Proton UR 500K launch vehicle. The Soviets decided to equip Zond with 2 solar panels attached on the opposite side of the body, spanning a total of about 9 meters. The spacecraft carried a proton detector and radio test relays among its instrumentation. Zond 4 was planned to be a precursor to a manned circumlunar flight. The objective of the Zond 4 mission was to explore circumterrestrial space and to flight test new systems and equipment. This was not to be a circumlunar flight. On March 2, 1968, Zond 4 was launched in a direction away from the moon. Some sources indicated that the launch away from the moon was to avoid trajectory complications with lunar gravity. In any case, the Zond 4 completed its first task of reaching an Earth parking orbit. Next came the most exciting segment of the flight, the second firing of the Block D upper stage, which sent Zond 4 to a 354,000 kilometer apogee orbit, 188 degrees away from the moon. Recall the spacecraft was not supposed to fly around the moon, but to a pre-calculated position approximately 330,000 kilometers from Earth. The main mission was to test out the technology of control, stellar correction, return to Earth, entry into a pre-calculated corridor, deceleration with 2 atmospheric passes, and landing. At this point, all onboard systems were working correctly. Then, on March 4th, the ballistic experts recommended a course correction, and the correcting engine was fired for a small burn. But the first correction failed. What began next was an epic episode of a series of stellar corrections involving inexplicable failures of the 100K star tracker. Each stellar correction session began with search, lock-on, and then an attempt to hold the star in the field of vision. Ground control tried to lock on to Sirius or Canopus, the 2 brightest stars, and drive Zond 4 between them. But some unknown problem appeared at the sensor's inlet. Next, the 100K star tracker began to react to the streams of peroxide illuminated by the sun that were being emitted from the attitude control engines. While there was time, ground control took a series of measurements to try to understand what was the problem and to learn which star could be best used for attitude correction. After using the command radio link to first set the 100K star tracker to a sensitivity corresponding to the luminosity of Sirius, ground control once again tried to lock on to Sirius. But again, stabilization failed. Keep in mind, troubleshooting the malfunctions and adjusting the sensitive electronic optical instruments at a range of 300,000 kilometers using the command radio link was hardly a simple operation. And it wasn't just 3 or 4 specialists dealing with this, but it was a raucous, argumentative staff of people who were skeptical of every new explanatory hypothesis. The sessions were long and tedious. On March 6th, the correction finally went through. Zond 4 passed through apogee and was returning to Earth. Now the objective was to enter the Earth's atmosphere in the predetermined corridor. To do this, the next correction needed to be conducted at a range of 160,000 kilometers from Earth early in the morning on March 9th, and the landing was predicted for a few minutes past 2100 hours. Then, on March 7th, the temperature of the hydrogen peroxide was cause for concern. It fell to -2 degrees. If it continued to drop and reached -4 to 5 degrees, Zond 4 would no longer have fuel for attitude control. Meanwhile, 3 ballistic centers were calculating and arguing around the clock whether one more correction was needed to enter the corridor. On March 8th at 3 a.m., successive measurement sessions began to refine the trajectory of the vehicle, returning at escape velocity. Over the course of the flight, ground control confirmed that the high-gain antenna was operating, but for some reason the signal-to-noise ratio was significantly lower than expected. The antenna experts, along with the radio specialist, worked on the problem, but they were debating and were unable to give an unequivocal report. The main ballistics group made the official announcement that for the time being it was not possible to give a clear answer as to whether further correction was needed. As the vehicle drew closer to Earth, a hectic and tense situation set in at the tracking station. It was the 7th day of the flight of Zond 4. Now all attention was concentrated on loading the settings into the sequencer to start up the program for the descent cycle. In this cycle, everything started from stellar orientation. Then the onboard computer was activated, and the gyroscopes of the dual-axis platform spun to provide stabilization during the first atmospheric pass. This is how the atmospheric skip landing was supposed to go. First, the descent module would separate from all the parts of the spacecraft that would burn up in the atmosphere. Then it would graze Earth's atmosphere. After reaching an acceleration load of 4 Gs, the vehicle would begin to change its aerodynamic quality by spinning around its longitudinal axis, thereby altering the position of the center of mass relative to the center of pressure. Then it was to skip away from the atmosphere and into space. 20 minutes later, due to the loss of speed during the first atmospheric pass and having flown part of its way in an Earth orbit, the descent module would then finally dip into the atmosphere and land in the predetermined area. According to the updated calculation, the first atmospheric pass would take place on March 9th at 21:19 hours and 18 seconds. 8 minutes before this, the descent module and the instrument aggregate compartment were supposed to separate. Beginning at 1800 hours, Flight Director Agadzanov started to take a poll of the readiness of all the ground facilities. The ship Risna responded from the Atlantic Ocean. It was supposed to pinpoint the L1 meteor streaking over it at 21:03 hours before separation. The ship Bezhitsa would pick up surveillance after separation at 21:20 hours in the Gulf of Guinea. Then Tracking Station 16 would establish communication with the descent module at 21:33 hours. The times were estimate and could shift forward or backwards by a minute or two due to inaccuracy in the ballistic experts' calculations. Descent was, above all, a trial run for the control system. At this time, the ground control services started to deliver reports. Quote, "The object is nearing Ristna's coverage zone. No word from Bezhitsa. According to the time, the vehicle has already left Bezhitsa's coverage zone, and Bezhitsa is silent. Airplanes have headed for the calculated landing area. The station in Tbilisi is receiving Zon's frequency. The object is flying per target indication. Tracking Station 10 has begun to receive. Axial acceleration 20 Gs. Reported by Ristna. Impossible." End quote. The National Air Defense Troops facilities calmly reported that the object had not been identified in the nation's airspace, which was completely contradictory data. Ground control attempted to make sense of it. Tbilisi and Simferopol had supposedly heard Zon. Bezhitsa and the ground control at Tracking Station 16 had not picked it up. That meant that an error occurred at Tbilisi and Simferopol. They simply wanted very much to pick up something. Evidently, they picked up something like a local television station's VHF signals reflected off the mountains. After comparing various sets of data and throwing out the improbable hypotheses, it was determined that it was not necessary to search for the vehicle on Soviet territory. If the Ristna had confirmed acceleration of 20 Gs, it meant that the self-destruct had activated. The system had been armed to go off in the event of a landing on the territory of Africa or Turkey. 20 Gs, that's quite a lot, even for ballistic descent. Alexei Leonov had been present and heard the comment. He said, quote, "We'll survive that if you don't blow us up." End quote. The Ristna had contact with the vehicle from 21:11 hours, 39 seconds until 21:19 hours, 58 seconds. Reception ended when the descent module plunged into the atmosphere. The vehicle did not ricochet out of the atmosphere, but continued its descent on a steep trajectory, and the Bezhitsa intercepted it at 21:21 hours as it left the plasma. At that point, communications finally broke off. The self-destruct system activated over the coast of Africa. But why did it not skip along the atmosphere like it was supposed to? More details came in from the ship Ristna. During the orientation session before the atmospheric pass, a number of things happened. A strong light bias was detected. Then the activation of the gyro-stabilized platform was inhibited. There was no star available, and finally the autonomous control system went dead. What was going on? Perhaps the films from the Ristna would help with the analysis, but it would take 6 days to get them. General Kamanin, the head of cosmonaut training, was outraged that the self-destruct system was not disabled. He said, quote, "Why blow up the descent module even if it is headed for Africa? We could test the parachute system. Ultimately, we would have found the module and learned a lot." End quote. But the ideologies in the Central Committee believed that not a single tiny rivet could end up outside the territory of the Soviet Union. Not because some technical secrets might be revealed from the fragments, but because a failure had occurred and it must be concealed. The Soviet Union must not and cannot have failures. But Kamanin was not happy with that explanation. He telephoned Tyulen and Mission and threatened that for the next launch he would officially demand that the self-destruct system be disabled regardless of the landing area. After the analysis was complete, the Soviets determined that the 100K's sensor lens shade, which was in the form of a tube with light occluding screens to protect against the sun's glare, was painted black. In the vacuum of space, under the effects of the sun's direct rays, the shade warmed up. The unstable paint sublimated, and its particles nebulized in the zero gravity and settled on the lens, thus causing the star tracker to fail. In conclusion, except for the star tracker, everything worked accurately the first time, without any glitches. The radio operators and ballistic experts provided good accuracy. Zond 4 entered the corridor with an error of just 2 kilometers, when they allowed for 10. The Soviets were moving forward in the correct direction. Listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. Thanks.